Imagine trying to cook a meal without being able to clearly see the kitchen around you. This is the case for more than 255 million people who experience moderate to severe vision impairment, including 49 million people who are completely blind. For many of these individuals, cooking can be difficult and potentially dangerous. Research has shown that 65% of visually impaired adults report significant difficulties cooking independently, often due to the risks associated with sharp tools, hot cookware, and limited visual awareness. As a result, many people rely on external assistance or avoid cooking altogether. From a sample of visually impaired users, studies have found that around 40% of evening meals are purchased outside the home, reducing independence and contributing to poorer nutritional outcomes. So we asked ourselves, how might we help visually impaired individuals cook more safely and independently using artificial intelligence and wearable technology? A number of assistive technologies already exist for people with vision impairment. Some applications can describe a scene, others can read labels and text, while services such as Be My Eyes connect users with a remote volunteer for assistance. However, these solutions are often fragmented and reactive. Users must typically hold up a phone, point a camera at an object, start a call, or actively ask for help before receiving information. In a busy kitchen, users don't just need to know what an object is. They need to know where it is, how close it is to their hands, and whether it poses an immediate safety risk. Current solutions rarely provide continuous awareness of the kitchen environment or proactive warnings before an accident occurs. To address this gap, we developed KitchenEye, a smart kitchen assistant that combines computer vision, voice interaction, and Meta smart glasses to provide real-time object guidance and safety monitoring. To build KitchenEye, we first created our own custom kitchen dataset. We recorded around 9 minutes of kitchen activity videos, manually annotated over 14,000 images using CVAT. Using this dataset, we trained a custom YOLO V8 object detection model capable of recognizing 10 kitchen-related objects, including knives, stoves, cookware, bowls, plates, spoons, spatula, cutting boards, and the user's hands. Here's a demonstration on how KitchenEye works. Kitchen! The users will hear a ding through their glasses speakers to let them know KitchenEye has heard them. Knife. User can then request for the object they're locating.
Knife 13 centimeters in front of left hand.
Kitchen. Cutting board.
Cutting board 19 centimeters in front of hand. Warning, knife close to hand.
KitchenEye continuously monitors distance between a user's hand and a risk object, and if they get too close, users will hear a warning through the glasses speakers.
Warning, hot pan close to hand.
Normally, a pan is not a risk object, but if both a stove and pan are detected, it is marked as a hot pan. Kitchen. Cooking pot.
Pot 5 centimeters in front of you.
Kitchen. Plate.
Plate 8 centimeters in front of you.
Kitchen. Spoon.
Spoon 8 centimeters right of hand.
Since the user receives all directions and warnings directly through the Meta Smart Glasses speakers, it allows them to safely navigate the kitchen while keeping both hands free for cooking. Looking ahead, we plan to expand the dataset to include additional kitchen objects, food ingredients, and cooking appliances to support a wider range of kitchen tasks. We also aim to improve distance estimation and spatial awareness, allowing KitchenEye to provide more accurate object guidance and safety warnings. Another area of future development is cooking state recognition, enabling the system to understand activities such as chopping, pouring, stirring, and cooking progress in real time. We also aim to incorporate food state recognition, allowing KitchenEye to identify changes in food appearance and condition, such as food beginning to burn, overcook, boil over, or spoil. This would enable the system to provide proactive alerts and cooking assistance beyond simple object detection. To learn more about our project and experience KitchenEye for yourself, please visit us at the UTS AI Showcase.